This is the Professor, CBMD PhD, and today's Tuesday, September 12th, 2023. It is 1:23 and 17 seconds, p.m. Eastern Standard Time, and today's research, improving transistors. So let's come to it here. Improving transistor performance through perovskite cation incorporation. Date September 11th, 2023. Source: Pohang University of Science and Technology. In semiconductor technology, both N-type and P-type transistors are necessary for constructing electronic circuits. N-type semiconductors facilitate current flow to the movement of electrons, while P-type semiconductors allow current to pass through the movement of holes. Despite this need for both N-type and P-type semiconductors for both electronic circuits, the development of efficient P-type semiconductors has been challenging due to the superior electron mobility of both semiconductor materials compared to hole mobility. This issue has been recognized as one of the top 10 challenges in technology by the nation. But tin halide perovskites represent promising P-type semiconductors with impressive hole mobility, making them candidates for next-generation high-performance P-channel transistors. As perovskites described by the chemical formula ABX3 consist of two types of cations, A and B, and one anion, X, the research team has been developing high-performance P-type perovskite semiconductor materials by combining various compounds. In 2022, they developed transistors with the best performance at the time using a combination of cesium tin iodide and reported their findings in Nature Electronics. In this study, the team ingeniously employed a mixture of three cations, formidinium, cesium, and phenethylaminium, in the site of perovskite ABX3 cations. While previous studies had used these cations separately, the study is the first to combine all three. As a result, the team succeeded in developing a high-quality P-type perovskite semiconductor layer with reduced defects. In building upon this achievement, they implemented transistors with high hole mobility, enabling faster computing with lower power consumption. As these results represent the highest performance level of P-type perovskite transistors reported to date, nearly equivalent to the commercially available low-temperature polysilicon transistors use no LED drive circuits. The research team has once again succeeded in developing the world's best performing transistors, surpassing their performance from the previous year. If the performance of low-temperature process P-type semiconductors improves to be comparable to N-type semiconductors, they can create electronic circuits with faster performance and greater enhanced data processing speeds. They hold hopes for this research to find widespread application in the electrical and electronic engineering arena, harnessing the potential of semiconductors and transistors. And this is the Professor of Space Technology, Advanced Physics, Mathematics, Computer Science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.